Okay, chapter 9. Chapter 9 is actually a rather easy chapter. Most of it deals with concepts you already know. Okay, so let's try this. Let's try that. Okay. Then emergent properties. Okay. First of all, the emergent properties of a neural network. First of all, emergent properties is something that you can only see as part of the whole and not as a tiny part of itself. Okay, like for example, you can understand parts of how the brain works by understanding how parts of neurons work, but you can never understand completely how the brain works by just studying a neuron. Okay, even though brains are made out of neurons. Okay, because that's the emergent property of a neural network. Okay. Okay. Plasticity is the restructuring of brain networks in response to sensory input and experience. Okay. Our brains are plastic. Okay. So we actually gain when we learn, we're always capable of learning new stuff. And by learning new stuff, our brains have to restructure as we learn them. Plasticity is better in younger people than older people. Okay, so as you get older, your brain becomes less and less plastic. So it becomes harder and harder to learn new stuff. Okay. So affective behaviors are related to things like emotion, feeling, especially feeling scared. Okay, our brains are actually driven more by feeling scared than survival than what you guys usually think about. Okay, higher levels cognitive behaviors are related to thinking. Okay, and logic and reasoning. Okay. Okay, so the evolution of nervous networks. So as we go, become more and more complex organisms, and this is more and more complex organisms, there is more and more room for brain development. So our brains are more and more developed. And if you look, I want you guys to focus in on these three, D, E, and F. Okay, so you can see, and so in fish, so birds or reptiles, and humans, we have the same structure. Sorry. We have a forebrain, we have a tiny little midbrain there, and we have a hindbrain. Okay, forebrain, midbrain buried in there, hindbrain. Okay, all the same structures. But you can see that the differences between us, if you look at the hindbrain, is not much different. But the forebrain went from a small, tiny piece to a much, much dominant piece. And that difference is why we're smarter than fish. The hindbrain in the back, the cerebellum and like all this like peachy stuff controls a lot of autonomic reflexes and stuff like that. The forebrain controls more reasoning and thought processes. So you can see like humans have the most developed forebrain of the three organisms shown here, and therefore they're more capable of reasonable thought, okay, or what we consider reasonable thought. Okay, so the development and the anatomy of the nervous system we'll basically skip. But again, you can see like what's happening here is the how do I put this? So the hindbrain and midbrain stay about the same size all the way through. What gets bigger and bigger as you go through these weeks is the forebrain getting bigger and bigger. Okay. Okay, so a lot of these concepts you should have covered in anatomy, especially development, and this stuff. Okay, this stuff right here. Okay, um, what gray matter and white matter is should be covered by anatomy. So hopefully remember that. Okay, the you should, again, this is all covered by anatomy. Um, so make sure you remember that. So I know in the anatomy textbook, the arachnoid is called the arachnoid motor, neuromotor, arachnoid motor, pia motor. Okay. Okay. So there is some stuff here. Okay. Okay. Okay, so a little bit physiology. Like the reason why this chapter is short is because there's some stuff. A lot of the stuff is covered in anatomy. The brain floats in cerebral spinal fluid. Okay, I'm sure you learned cerebral spinal fluid in anatomy, but what you got to understand is how it's made and how and what it does. Okay, what it does, your brain is not is a lot softer than you guys think. It's actually softer than jello. Okay, so if I take a brain, I just set it on a desk, it would squish. Like it would squish down to the point where the brain dies. Okay, so your brain is not just capable of sitting in your head. Okay, it literally has to float in your head, and it floats in the cerebral spinal fluid. Okay, the cerebral spinal fluid um, is a salty solution, similar to plasma. Basically, they take blood, your brain takes blood, takes the plasma portion out of it, and pumps it into your brain. And that is the cerebral spinal fluid. So it transports nutrients into it, it transports oxygen into it. Okay. But it is controlled. Okay. So a lot of things that are not or in your blood are not in your brain. Okay. All right. So it's contained within the subarachnoid space here. So you can see it's actually like there's there's a subarachnoid, there's an arachnoid membrane, and underneath the arachnoid membrane, between the arachnoid membrane and the pia mater is the spidery space right here. That is where the cerebral spinal fluid is flowing. Okay, it eventually drains back into into the fluid here, into the venous sinuses. Okay, and it's pumped back into the bloodstream. Okay, it's produced by the ventricles of the brain, and eventually it comes out, leaks out through the subarachnoid membrane surrounds the brain, also goes down the spinal cord, and this is finally what it actually looks like. Okay. Okay. So cerebral spinal fluid reabsorption. So if you constantly make it, you have to reabsorb it. Okay. Or else it would just make more and more of it, and that would cause serious problems. Okay, you'll learn that in pathophys. If you have a cerebral spinal fluid blockage, that causes major problems. Okay, all right. So for physiology, you have to really understand what the cerebral spinal fluid does. Okay, because that will show up on your quizzes or exams. I haven't determined which one. Okay. The blood-brain barrier protects the brain. So again, you probably learned this in anatomy, but I want to be very specific. You do have to know what causes the blood-brain barrier and what it does. Okay. Okay. Next thing, neural tissue has specific metabolic requirements. Okay, and that's really important. Okay, your neurons are very different from the rest of your body. The neurons are extremely sensitive to two things: oxygen and glucose. Okay, your brain uses about 20% of the energy that you consume. Your brain is also 3 pounds. Okay, and it uses a lot of protein. Okay, this is why humans have such large brains, develop such large brains after the discovery of fire. Okay, after the discovery of fire, we were able to cook stuff so we could eat more stuff. Okay, it required less chewing, less digestion, so we had more energy. That energy fueled brain growth. Okay. Okay, so neural tissue has special metabolic needs, oxygen and glucose. So if you shut off supply of oxygen, the first, like if you stop breathing, the first location where people worry about is not the heart, it's not your lungs, it's your brain. Your brain needs oxygen, okay, and glucose. The rest of your body can burn fat and live off fat. Your brain cannot. Okay. So glucose. So the brain is responsible for half of the body's glucose consumption. So a lot of energy. Okay. All right. So the spinal cord, you should already understand all this stuff. Okay. Ascending tracks, descending tracks. You should already know. We're going to skip the spinal tracks. Okay. But ascending tracks and descending tracks, you should know what they are. Okay. Okay. You should know what the gray matter does. Okay, what the three horns do here. Okay. You should already know what a spinal reflex is. Okay. All right. You should definitely know the functions of the cranial nerves. Okay. So it's listed on that chart. So make sure you understand everything from the cranial nerves. Okay. You should understand the functions of the brainstem. Okay. So the functions of the brainstem. So what functions it controls. So like the medulla, the pons, the midbrain. Okay. Okay. The functions of the cerebellum, the functions of the diencephalon. Okay. You skip the skull, diencephalon. Okay. Functions of the hypothalamus, definitely on there. Okay, definitely a really important thing. When I used to study brains, the hypothalamus was like per unit mass, the most important part of the brain. Okay. Okay, so we're going to skip these guys. You should learn that anatomy. Okay. Okay. What we didn't learn in anatomy probably was the limbic system. Okay. The limbic system. So. Okay. So the limbic system controls emotions, and stuff like that. So and memory. So emotions and memories are actually closely tied up, which is which is why like memories provoke emotions a lot and vice versa. Um, so the limbic system. Okay, so if I stand correctly, yes, this controls the limbic system is involved in emotional states. It also involved in behavioral states. So behavioral responses also tied into emotion. Okay. Um, okay. So sensory cognitive. Okay. So you should know that already. You should learn that already. Okay. Okay. So cerebral batterization. Okay, so this is kind of an important concept that we sort of gloss over in anatomy. We did it with the eyes. Okay, so one of the things that we have is two hemispheres, right? So one on the left side, one on the right side. Mostly what's controlled is contralateral. So like the right brain controls the left side, the left brain controls the right side. Okay, but information is coming from both sides, so they have to communicate with one another, and so they have the two sides of the brain has to lateralize. Okay, so most of it is done through the corpus callosum. Okay, the corpus callosum is what controls the two halves of the brain and connects them together. Okay, um, so you should be able to answer these questions, right? So the two halves of the brain are slightly different. Like when we talk about speech, Wernicke's area is only located on one side of the brain. Broca's area is only located on one side of the brain. It's usually on the left, but not always. Okay. Um, and so you have things like right here, you write you write most people write with their right hand, so the right side dominant. So their left brain dominant. So here the writing is on this side, the analysis by touch is on that side. If you're left-handed, you're just uh, right hemisphere dominant, and um, so this is switch. Okay, so hopefully that makes sense. Like many famous artists, including Leonardo da Vinci and Michelangelo, are left-handed. So there's a great amount of musicians and stuff that are left-handed as well. And so this is the analysis by touch. Okay. So they're right hemisphere dominant, so they have more touch analysis and stuff like that. Okay. Okay. We'll skip imaging techniques. Okay. Um, so one of the special things about our brain is our sense of perception. Okay, I'm sure everyone can envision a square here, even though there isn't. Like there's actually nothing there that's different. Okay, so there's no actual square, but we actually perceive one because our brain is very good at tricking our minds into thinking like I'm sure you look at this and go, this is a cube. No, it's not. It's not a cube. Cubes are 3D objects. This is not a 3D object, right? It's just like square and whatever shape that is. Like it's we we add perception to it. Okay, we interpret things um, at different levels. Okay. Okay. This stuff you should already know. Okay. All right. The RAS. Okay. We'll get the we'll get some of these guys. But you should know you should know this, you should know A, you should know B, C, not so much D. Okay, so just the sorry. Well, you should know. You don't need to know where the neurons originate or terminate, but you should know the functions. Okay, so where serotonin functions, where norepinephrine functions, where dopamine functions, acetylcholine, especially dopamine and serotonin, because those are actually like where drugs play a huge role in these things. Okay. All right. All right. We'll end this right here. Actually, I'll record the second part, a short little video, but it deserves a little video because I'm going to sleep a little bit and stuff like that, and memory and stuff. And I think that part is a little harder for you guys to digest. So, and that's newer information. Okay. So I'm adding another layer to your knowledge in the next chapter. All right. I will see you guys later.